Hello, guys. I hope you're good. I'm also good. Anyway, let's continue with our lessons. So today we'll be discussing change of variables, which I can also call U substitution. So I can also call this U substitution. U substitution. So U substitution is a method whereby we rewrite our given integral in simple form, because the way it's given to us, it's impossible to integrate, or it's not simple to integrate it. So just like the integral question that I attached here, so I'm going to use it to explain this U substitution. So because of that the first thing that we need to do on integration is to simplify before we can apply any rule. So you have to think of simplifying before you can apply any rule. It could be a bypass, strict substitution, or any other rule of integration. So on this integral question, when we check our integrand here, we cannot simplify, because of even if we can change this root to become an exponent of 1 over 2, then still you cannot be able to multiply x and this thing. So there is nothing that you can do here to simplify our integrand. So hence we use U substitution so that we can be able to integrate these given things. So that means we're going to rewrite our given integral in terms of U now. So what you need to do now, you just need to, so we always let something that is inside the brackets or something that is inside the root or whatever to be your U. For this case, we're going to let, so we're going to let our U to be equivalent to 2x minus 1. And then we derivate with respect to U. So du dx will be equivalent to what? Will be equivalent to just 2. And then after that, we rewrite our given integral with respect to U. So yeah, let's start. So here we can also, from this U, we can again make U to be we can make x the subject of the formula here, so that we can be able to substitute that x there. So from this, let's make x subject to the formula. So x there will be equivalent to U plus 1 divided by 2. And then from here, now let's rewrite that. Okay, we also need to make dx the subject of the formula from this one. So dx there is going to be du over 2. So therefore, dx here is going to be 1 over 2 multiplied by du. So now we just need to rewrite this integral with respect to U. So now let's go. So that means our integral is going to be something like this. Our x is equivalent to U plus 1 over 2 multiplied by root of U, because remember we said 2x minus U is equals to U. So this is going to be multiplied by U to the power 1 over 2. And then we have our dx here. So our dx is equivalent to 1 over 2 du. So this is du over 2. So just like that. Then from there we need to multiply. So we need to multiply. So what are we going to do here? 2 and 2 will multiply out, and then this U will multiply this numerator. So at the end of the day, we'll have 1 over 4 outside there. This 1 over 4 comes from 2 multiplying 2 there, and then it becomes 1 over 4 there, because 2 and 2 are denominators. And then U multiplies U to the power 1. That's going to be U to the power 1 plus half, that's your 3 over 2. That's your 3 over 2. 3 over 2 plus u to the power half, and then you close, then that's your du. Then now you can see that this is simple. Now we can just integrate this one. So from here you can see that now your answer for this integral is going to be u to the power 3 over 2 plus 1. So 3 over 2, so this is going to be 3 over 2 plus 1, and then 3 over 2 plus 1, that's your 5 over 2. That's your 5 over 2 divided by 5 over 2 plus that 1 over 4 is multiplying everything, so we can I can open here. Yeah, I can just open a bracket here so that I don't have to write long things, and then u, and then we add half on 1 over 2. That's going to give us about 3 over 2 divided by 3 over 2, like that, and then plus c. And then let's first rewrite this thing. So this is going to be 2 over 20. So this whole thing, this is going to be 2 over 20 because 2 will go up there, and then 5 times 4. So this is going to be 2 over 20. 2 over 20, which is simply just 1 over 10. And then we can change that u to a square root, this exponent of 5 over 2 to a square root. So this is going to be multiplied by square root of u to the power 5 plus, and then 1 over 4 multiplied by 1 over 3 over 2. So that's going to be 2 over 12, right? 2 over 12, that's 1 over 6. So this is going to be 1 over 6 multiplied by square root of u to the power of 3, then plus c. But let's not forget what our u was. So our u was 2x minus 1. So we need to substitute back what our u was. So this is going to be 1 over 10 multiplied by the square root of 2x minus 1 to the power of 5 to the power of 5 plus 1 over 6 square root of 2x minus 1 to the power of 3 plus c. So yeah, that is the thing, guys. So u substitution, we use it to make our integral, to rewrite our integral in simple form, as well as to be able to integrate, because some of the other integration questions, you will see that if you don't let something to be equals to you cannot do anything. Just like this one, there was no way that you could integrate this without letting something to be equals to you. And then one more thing that I'll advise with respect to u, which one do you let to be your u? It's always something that's inside the root. You can memorize it like that. I think that trick always works. So whatever that is always inside the root or inside the bracket, we tend to always make it our u. So please memorize it like that. All right. So this u substitution works together with this other method that we call general power rule for integration. So now let's discuss this one, and then I'll explain the difference between two of these things. So general power rule is this one. So our general power rule is this one. Let me write it down. So we're going to have integral of, so I'm writing the rule here. So f prime of x multiplied by f of x to the power of n dx. And then the answer for this integral is always f of x to the power n plus 1 divided by just n plus 1 plus c. And then of course your n should not be equals to -1. Otherwise, if your n is equivalent to n, which is, if your n is equals to n minus, if your n is equivalent to -1, I mean, then you have another, we have another rule for that, which is going to be just your ln. So this means that your f prime of x is divided by your f of x dx, and then the answer for this is just your natural log. Yeah, natural log plus c, right? Plus c. So yeah, but then so yeah, this is the rule. So this rule says that you have a function and its derivative. So when you integrate a function and its derivative, you just take the original function, then you say n plus 1 divided by n plus 1 plus c, just like that. So this is the general power rule. So you have to always look out for this so that you make your life easier. And then sometimes, and also you have to take note of the n. So if your n there is equivalent to -1, then it is this one. It is the one. It is ln, which was derivated. It is the natural log which was derivated. So you have to say your answer is f of natural log of f of x plus c. So yeah, you have to always look out for that n. So yeah, let me just give you an example on this general power rule thing. Then from there we're gonna start. So yeah, let's start. So this is what I was trying to say with regards to general power rule. So you check the things that are multiplying each other, then you see, is there a function and its derivative. So you're going to check when I derivate this x cubed minus 5, what do I get? I get 3x squared, right? Meaning that this 3x squared is the derivative of this. So meaning that this is the f of x and that is the derivative, meaning that I can be able to use a general power rule here. So meaning that the answer for this is just going to be simply x cubed minus 5 to the power okay, let me first rewrite before I confuse you. Let me first rewrite this in this way, whereby I've changed the root into an exponent form. So this is going to be 1 over 2 dx. So you can see that our n is not equivalent to -1, so therefore we can say this is general power rule, right? So our answer for this is going to be just, so our answer is going to be x cubed minus 5 to the power 1 over 2 plus 1 over 2 plus what? 1 over 2 plus 1, it's going to be 3 over 2. Why God, my mind is getting lost. Divided by 3 over 2 plus c. So this becomes your answer. Then of course we can rewrite this in this way, whereby we say this is equivalent to 2 over 3 multiplied by the square root of x cubed minus 5 to the power of 3 plus c. So remember what I said, guys. I say that use substitution, we use it to make our integral in simple form, right? So, and one more thing is that we also use it for making our integral to be able to be integrated, so that it can be so that we can be able to integrate it, because without letting it to be equals to u, then we cannot be able to integrate. So u substitution and general power rule work hand in hand. So it means like you can always use u substitution in most cases if you don't know general power rule. So general power rule, it's more like it's a shortcut. U substitution, it's a long way sometimes. So there are cases whereby u substitution is a must, and there are cases whereby u substitution is not a must. So in this case, you can either solve this question using general power rule like I did, which was the fastest way, and I recommend this one. And then also u substitution can work here. So let's try to solve it using u substitution, and then you'll see that it is the same thing. So what did I say about u substitution? I said always let something that is equals to something that is inside the what, the brackets, to be equals to u. So here, if we wanted to, if we were solving this using u substitution, that means we're supposed to let our u to be equivalent to x cubed minus 5. Then we differentiate this with respect to u, so du is going to be equivalent to 3x squared. Okay, 3x squared multiplied by dx, and then you make dx apply to the formula. Or we don't have to for this case, because of we already have 3x squared, so it's fine. We can just leave it like that. Okay, so now we can rewrite our integral in terms of u. So that means we're going to say okay, they say 3x squared dx, 3x squared dx equals to du, and then x cubed minus 5, it is equals to u. That means here we're just gonna say u to the power half multiplied by du, and then we integrate this. So when you integrate that with respect to u, that's just going to be u to the power 3 over 2 divided by 3 over 2 plus c, and then you then substitute back your u. So when we substitute back our u, we're going to get 2 over 3 multiplied by square root of x cubed minus 5 to the power 3, then plus c. So you can say that this thing and this thing is the same thing. So it's up to you basically that which method do you prefer. So yeah, it will be totally up to you. So yeah, that's the thing. So anyway, yeah, that's the thing. That's what I can say. We have another method here that I can also, okay, we have another question that I can also use to explain what I was talking about here. So you see this question. So remember, guys, first thing that you need to ask yourself, can I simplify this thing? So if you can, you need to simplify. It will make your life easier whenever you get your integral. So when you check this question, can we be able to integrate this? Of course, right? We can. So yes, that means for us to be able to integrate this, you can either use, I just want to show you that there could be many methods. So I want to use this question to solve using different methods. So if you thought of simplifying, then that means you're going to say you're going to multiply out there. You will have x squared plus 2x plus 1, and then this is the x. Then you can integrate this. When you integrate, that is going to be x cubed over 3 plus 2x squared over 2 plus x plus c. So you see, we did this. But then, now that we know about general power rule, that means we can also try to see if it could work here. Yes, it could. So let me show you. If you thought of general power rule, then you're supposed to do this. So remember, general power rule, we check if there is a function and its original function. So, and always the function, the thing that is always inside the bracket, we tend to use it as our f of x, and then whatever that's outside the bracket, we tended to use it as our f prime of x. So when we check x plus 1, and then when we derivate x plus 1, what do we get? With respect to x, we're going to get 1, right? The 1 which is here, the constant which is here already. So meaning that we can be able to use general power rule. And if we go about it, then that means that our answer is just going to be x plus 1, which is our original function, and then 2 plus 1, that's our what? Our 3 divided by 3, and then plus c, just like that. And then we will be done. So if you simplify this, you'll see that it will take you back here. So these answers are the same. So yeah, you can just take your time and then you expand these, you divide by 3, it should take you back there. Anyway, I'm not gonna do that, it's for you. But yeah, the two answers are the same. So this is one of the most important thing that I wanted to emphasize with you, is that in integration you can have two different answers, that two answers that looks different, but they are the same answers for that one question. You see this question, we have two different answers when we use two different methods. Both answers are correct. So don't be confused someday whereby after an exam your friend says I got this answer and you say you got this other answer which are different. So just know that for one integral question we can have two answers and both of them are correct. So that's one more thing that I wanted to tell you. Anyway, let's continue and do some activities. Okay, activity 1, we have to integrate this following question. So let's go. Remember, first thing, let me write some things that you need to remember here. So let's write down questions to use to answer the questions. Questions to use so that you can integrate. So let me just write this down. So I just want to write down questions to use so that you can be able to integrate. So the first question is that number 1, we have can I simplify the integrand? So remember the integrand, it's what's inside the integral, right? So can you simplify that integrand? If you can, please simplify. Then number 2, do I have f of x and f prime of x? So number 2, you ask yourself, if Okay, the first question you ask yourself, can I simplify the integrand? If you can, then you are going to simplify, then you so that you can be able to integrate. Number two, you ask yourself, do I have f of x and f prime of x? So you check your thing. Do I have f of x and f prime of x? If you do, then you know that you can be able to use general power rule. Then you use general power rule. Then otherwise, if you don't have f of x and f prime of x, that means you have to let something to be equals to u. Okay, yeah. So yeah, those are the two questions that you need to use always when we are doing our questions. So yeah, let's go. So let's start. Number one, we have integral of 4 plus x squared dx. So when we check this, can we simplify this? Yes, that means we can either that means we can simplify this by expanding, and then we integrate from there, which is correct. Another one can say okay, I know that's true, but I know that also general power rule is applicable because of I have f of x, which is 4 plus x, and then I also have the derivative of this f of x, which is 1, because the derivative of 4 plus x is going to be 1, and we have a 1 here, so meaning that we can just use general power rule. So let's just go with general power rule to make our life a lot easier, to be easy, right? Who doesn't like an easy life? So that means, yeah, when we use general power rule, this is just going to be 4 plus x to the power of 3 divided by 3 plus c. Of course, if you didn't want to use general power rule, so if you didn't want to use general power rule, then you would have to rewrite your integral in this format and say that your 4 plus x 4 plus x dx, okay, and then you multiply out there, you're going to get what? 4 times 4, that's your 16, plus 8x plus x squared multiplied by dx. Then you integrate here. From here, it's simple to integrate. Then your answer for this is just going to be 16x plus 8x squared divided by 2 plus x cubed over 3 plus c. Okay, I ended up doing two methods, although I said I want to do one. So another thing, guys, both answers are correct. I repeat, you can have two solutions for one integral question. Both of them are correct, provided that you didn't do a mistake, of course. Yeah, let's continue. So we have another question. Guys, now that you have gained confidence, can you please try to pause the video and then you work out on these problems on your own and then resume later to check the memo, of course. Because you can't be watching a movie here. It's not a movie, right? It's a lesson. So you must be doing some work there on your side as well. So when we check this one, let's start. Can we simplify this? There is nothing that we can do here. So we check. Do we have a function and its derivative? Of course we do, because of p plus y. If it's our f of y, if we let this to be our function, then the derivative of this is 1, the one that we have already here. So anyway, we can also rewrite this integral so that it's easy to see what I'm talking about. So this could be p plus y to the power negative half dy. So can you see that our p of y, when we derivate it with respect to y, we're going to get 1, which is here, 1, which is here. So, and also our n is not equivalent to -1, so meaning that we can be able to use general power rule to integrate what we have there. So that means the answer for this one, when we use general power rule, is going to be 2 plus y to the power negative half plus 1, that's your positive half, and then divided by a half plus c. And then of course we can rewrite this answer in this format. The 2 will go up there, and then Hey, why did I write negative half there? I'm sorry, guys. I said it's positive half. And then we can rewrite this in this format and say this just p plus y and then plus c. So that's your answer. And then we have another question, of course. So yeah, feel free to pause the video and then resume later to check them. We have another question here. 2 minus t to the power 2 over 3t dt with respect to the, so we're integrating with respect to dt. So we ask ourselves, can we able to integrate the two can we simplify these, guys? No, there is nothing to do here. And then can we apply general power rule, like meaning that do we have f of x and its do we have the function and its derivative? So we check. If we let 2 minus t to be our function, do we have the derivative of 2 minus t? Yes, we do, but it's not really make sure, because of we're supposed to have minus 1 here, but then we don't have minus 1. So you again use the method of cooking. So meaning that you must cook that negative 1 because of it's not there. So meaning that you must rewrite this in this format. You write minus 1 here, 2 minus t to the power 2 over 3 dt. But then we didn't have this minus 1, so we should cancel it out because of we are not changing the equation and integrate our own things. So now you must put another negative 1 outside there so that this negative 1 and this negative 1 they cancel out, so that we still have the same equation. But then we make use of this minus 1, so we don't really have to go back there. Otherwise, if we go back there, we'll not be able to integrate. So we make use of the negative 1 that is inside there so that we can be able to apply our general power rule. So now when we check our thing again, we have this as our function, and the derivative of it with respect to t, we get negative 1. So meaning that for this case, we can be able to use general power rule now. So okay, the answer for this is just going to be the negative 1, which is this one on the outside, multiplied by, now I apply my general power rule, which is going to be 2 minus t to the power 2 over 3 plus 1. So you can use your calculator, or if your brain is always in good condition, you can use it as well. You're not limited. So I'm gonna use my calculator. Sometimes my brain is not make sure. So that's about 5 over 3. When we add 1 on 3 over 2, we get 5 over 3 divided by 5 over 3 plus c. Then of course we can rewrite this in this format. We can just say this is equals to minus 3 over 5 multiplied by 2 minus t to the power 5 over 3 plus c. And yeah, ta-da, that's your final answer. And then yeah, that's it, man. That's it. Anyway, let's continue. It's easy, right? It's easy. You're gonna get a torture, right? I trust you. Anyway, let's continue. So we have the integral of a minus x cubed dx. So we're integrating this with respect to x. Remember, guys, to pause the video so that you can give it a try, and then you will resume later to check the memo, of course. So look at it. So we have x. So we ask ourselves, can you simplify this first? That's the first thing first, so that we can be able to integrate. Can we simplify this? Yes, we can, by multiplying throughout. So meaning that we can multiply out and expand, and then you'll get your a cube, wara there, and then you integrate there. But then that's a long way to freedom, right? Why don't we just use general power rule, because that's easy for everyone, right? So yeah, for general power rule, we check, can we do we have a function and its derivative? So you check now, if we let a minus x to be the function, then what's the derivative of a minus x with respect to x? Of course, that's a minus 1, but then we don't have a minus 1. But then again, we can cook -1. So we use method of cooking, we cook -1. So meaning that you're first going to rewrite this and put -1 here, you put -1 here, and then a minus x cubed the x. So we didn't change the equation here because of -1 by -1 we get our +1, which is there. So meaning that this is still the same thing. However, we can make use of this -1 and integrate this using general power rule. So from this we can now see that a minus x, as a function, its derivative is going to be -1. So then now we can be able to integrate. So the answer for this is just going to be -1 multiplied by what? Multiplied by a minus x to the power 3/2. 3 plus 1 there, that's going to be your 4 divided by 4 plus c. So then this becomes your answer. You can again use that method of simplifying first by multiplying out and then integrate. It will still be the same answer. So yeah, let's see if we can do something else. Okay, so let's check another question quickly. So this is going to be what? Okay, so now we have this question as cubed root of x squared minus 2x plus 1. So we want to integrate, right? We start with those two questions that I've told you about. Can we simplify this? Remember, when you ask yourself, can I simplify this? You have to think out of the box. You cannot allow yourself to think within the box, or yes, you cannot allow yourself to think within the box. That means you must think that you must make sure that you have thought, and yeah, you have thought about it. So when you ask yourself, can I simplify this? You must make sure that, yeah, when you conclude, it's really true that you can be able to simplify. So yeah, can you simplify this? Yes, right. So how are we then going to simplify this? Then that's simple. When we check our thing inside the cubed root, we can be able to factorize it. So when we factorize that, so let's rewrite this. So let's rewrite this. So this is going to be the cubed root of what? Of x minus 1, the x. Then of course x minus 1 and x minus 1 are the same thing, so we can rewrite this again further and say this is x minus 1 squared. Then what can we do from here? We can again rewrite this in this format and say this is so we're going to change the cubed root there, and then this will make it to be 2/3 the x. Then from here you can see that now we can be able to integrate, right, using general power rule, of course, because of now if we let our x minus 1 to be our function, then the derivative of this x minus 1 with respect to x is going to be equals to 1, and we already have the 1 here. So let's just integrate this using general power rule. Then this is going to be x minus 1 to the power 3/2. So 3/2 plus 1. When we add 1 on 3/2, we get how much? We get 5/3. So we get 5/3. So this is going to be divided by 5/3 plus c. Then of course you can rewrite this answer in this format. So 3 is gonna go up. We're gonna have 3/5, and then this is the cubed root of x minus 1 to the power of 5 plus c. Yeah. So ta-da, you now have your final answer. So those are the few tricks that we use when we doing different types of questions. So yeah, let's see if we can solve another one quickly. So yeah, we do have another question here, which is x plus 1 divided by the square root of x squared plus 2 minus 4 dx. So we check, can we simplify this? Then you think, you realize that no, you cannot be able to simplify this. Then we move to the second question. Can we apply general power rule, or do we have a function and its derivative? So when we check, if we let x squared plus 2x minus 4 as our f of x, or as our function, can the other thing be the derivative of it? So that means you can first derivate this. So when we derivate this one, this is going to be 2x plus 2. You check, do I have 2x plus 2 there? No. But it looks like I can cook it. Then you cook it if it's possible. So we're going to introduce a method of cooking again here. So, so just because of the derivative of this thing that we want to make as our f of x, or as our function, it's 2x plus 2. So we must force this to be 2x plus 2. So what are we going to do? It means that we're going to multiply this by 2, because of, if we multiply by 2, we're gonna get 2x plus 2, and then yeah, it will be easy from there. So that means I must multiply this by 2, right? So that I can be able to okay, let me see. All right, before that, guys, let's first start by rewriting our thing first. So we have x plus 1 multiplied by x squared plus 2x minus 4 to the power of negative half dx. So we have, so yes, because of n is not equal to negative 1, so we can be able to use general power rule. And then from there, we check. So this, if we let this to be our f of x, the derivative of it must be 2x plus 2, right? But then this is not 2x plus 2, so we must cook it. So for it to be 2x plus 2, we must multiply it by 2. But then 2 was not there initially on our equation, so we must cancel it out by multiplying it by 1 over 2, so that 2 and 2 cancel out, and then we still have the same question that we are solving. So now our general power rule can be applied nicely because of what? Because of we have what is this? We have a function and its derivative there outside there. So 2x plus 2, it's the derivative of this. So meaning that our answer for this is just going to be 1 over 2. So this 1 over 2 is this one that is outside there, and then we multiply by the other thing there. So we have, so now I apply my general power rule. It's going to be x squared plus 2x minus 4, and then I add 1 here on minus 1 over 2. That's going to give me positive 1 over 2 divided by 1 over 2, and then plus c. Then 1 2 multiplied by half, that's your positive 1, and then we change this positive exponent of half to a square root. So this is going to be the square root of x squared plus 2x minus 4 plus c. So then this becomes your answer. So yeah, that's it for a question. Let's quickly see if we can solve another one. So we have we now have what is this? What is this? We now have x8 squared divided by x cubed plus x squared plus 2 to the power 3 dx. So we're supposed to integrate this as well. So let's continue. So we ask ourselves, can we simplify this? Definitely no. There is nothing that we can do here. Okay, we move to the second question. Can we do we have f of x and its derivative? So do we have a function and its derivative? So we check. If we let x cubed plus 2 to be our function, can the other thing be the derivative of it? Yes. So when we check the derivative of x cubed plus 2 with respect to x, that's going to be your 3x squared. Then you check, do I have 3x squared there? I don't, but I have x squared. So meaning that I can cook the 3, because we can always cook the numbers, but you cannot cook anything of x, meaning that we're just gonna apply. So we can rewrite this nicely first, of course. So I can write my 8 outside here, and then I write my integral, and then I say x squared, and then what? X cubed plus 2 to the power of negative 3 dx. And then we say that the derivative of 3x squared plus 2 is what? It's 3x squared. So we should force 3x squared here. So meaning that I'm gonna put a 3 here and then put 1 over 3 outside there, so that 3 and 3 cancel out, and then we go back to the same question. So we didn't change the question here. However, we can make use of 3x squared so that we can use general power rule. Also because of our n is not equals to negative 1, so we can be able to use our general power rule. So from here, the answer for this is just going to be 8 over 3 multiplied by, so I apply my general power rule, which is just going to be x cubed plus 2 to the power negative 3 plus 1, that's your negative 2 divided by negative 2 plus c. Then you do your maths there. We can again take that one down there so that we can write it in positive exponents. So it's going to be 8 divided by 2 here. For this case, it's going to be 4. And then negative, so it's going to be negative 4 over 3 multiplied by 1 over what? X cubed plus 2 to the power of 2 plus c. Then that's your final answer. So yeah, that's it, guys. Yeah, I hope you are getting confident with how to solve these things, because in the test you must be confident. You must. If you're not, I see danger. Anyway, let's continue. Feel free to pause the video so they can work out on these problems as well, and then what? Resume later to check the memo, of course. Same thing every time. Yeah, it's not a movie, it's a lesson. Yeah, anyway, we go back to the questions. Remember, we must integrate. You cannot integrate without those questions. So you ask yourself, can I simplify this? You check it. You say, nah, I can't. Or you can you? You cannot, right? You can't. Then you move to the second question. Do we have a function and its derivative? So you check. Do I have this? Do I have what I'm talking about here? You check. Yeah, you do, because of the derivative of tan 4x, it is equals to 1 over 4. Or tan 4x is going to be equals to 1 over 4 sec squared of 4x, but then we don't have a 4. So what do we then do? So meaning that we must cook the what? The 1 over the 4. So that means that we will need to first rewrite this. So you are going to say tan of 4x multiplied by 4 sec squared of 4x dx. So I cooked my 4, but 4 was not initially there, meaning that I must cancel it out by multiplying by 1 over 4. So we have identified that tan 4x must be our f of x, and then the other one is the derivative of it. So meaning that from here we can be able to use general power rule, right? So our n is going to be equals to 1. So if our n is equals to 1, we can be able to use general power rule from there, because we can, the only way whereby we cannot be able to use general power rule is when our n is equal to -1. So yeah, now let's make use of our general power rule. So for the answer for this is just going to be 1 over 4 multiplied by tan 4x to the power of what? 1 plus 1 is going to be 2 divided by 2 plus c. So that is the same as 1 over 8 tan squared of 4x plus c. So then that becomes your answer. Then yeah, from there you then try to solve another question. Remember, you must solve until you are too confident, until you don't even need to solve these things by calculating. You can just sit them in the head and then you see the answer. So yeah, now we have this question. So yeah, we start. Can we simplify this? No. Do we have a function and its derivative? You check. So if you let x minus 1 to be equals to your f of x, is the other thing equals to your derivative. So x minus 1, when we derivate it, it is equals to 1. So we have 1 here. So 1, we already have it, but then we can rewrite this nicely so that you can see what is going on. So x minus 1 to the power minus 3 dx. So we already have a 1 here. So meaning that we can be able to use general power rule also, because of n is not equals to -1. So it allows us to use general power rule. So this is just going to be equals to x minus 1 to the power minus 2 divided by -2 plus c. Then of course you can rewrite this nicely by saying this is equals to -1 over 2 multiplied by x minus 1 squared plus c. So then that becomes your answer. Okay. Then you're not supposed to stop. You should integrate until you you no longer want anything with these integration things. So yeah, we have another question here. So yeah, let's go. So guys, remember to pause the video so that you can try these problems on your own and then resume later to check the memo, of course, just to check how I've done it. Okay, so yeah, we start. First question first, can we simplify this? No. Do you have a function and its derivative? Not really, because of we need to cook the coefficients. So meaning that we need to rewrite this and nicely. So we need to first rewrite this nicely. So that's going to be 2 minus 3x to the power of half dx. So if we let 2 minus 3x to be our f of x, so the derivative of this should be minus 3. So meaning that outside this we should have the derivative of this. So we can cook, because we are always allowed to cook numbers, right? So you can cook minus 3, you put it there, and then you put minus 1 over 3 outside there, so that you don't change your equation. So this and this are still the same thing, because negative 3 and negative 3 are going to cancel out. You're still going to have that. But then we can make use of minus 3 and that, and then we apply our general power rule. So this is going to be, the answer for this is just going to be minus 1 over 3, which is the one that is outside there, and then you apply a general power rule. That's going to be 2 minus 3x to the power half plus 1, that's your 3 over 2 divided by 3 over 2 plus c. And then of course you can multiply out. Here the 2 is gonna go up, and then the 3 and 3 will multiply out, so you will end up having negative 2 over 9 multiplied by, and then you can change this to a square root, so that this becomes 2 minus 3x, 2 minus 3x to the power of 3, and then plus c. Of course, you should not forget. Then that then becomes your answer. Then from here you can do another question. This questions. So we now have this integral of, so I'm just checking this up, sorry. So we now have integral of what? We now have integral of x squared minus 1x dx. So we're gonna do the same thing. Can we simplify this? Yes, we can just multiply out, and then we get our thing. So let's just do it. We have been applying, what is this? We have been applying the other one, general power rule, for quite a long time now. Maybe we might even forget how to simplify. So let's just simplify for the sake of this question. So this is what? X cubed minus x. So this is going to be x cubed minus x, then dx. Then now we can be able to integrate. That's going to be x to the power what? 3 minus 1. That's 3 plus 1. So that's going to be x to the power of 4 divided by 4 minus x squared over 2 plus c. Or we can just apply general power rule by first rewriting that thing nicely, because of, if we let this to be our f of x, we can make this as well to be our f of x by cooking the coefficient, because of, we know that the derivative of x squared minus 1 should be what? Should be 2x, right? So let's rewrite this first. So that means here we have x squared minus 1 multiplied by 2x dx multiplied by 1 over 2. So the 2 and 2 cancel out, we go back to the same thing. However, we can make use of 2x and this one. So we can apply general power rule from there by saying that this is the answer for this is going to be this 1 over 2. 1 over 2 multiplied by, I now apply general power rule there, that's going to be 2 divided by 2 plus c. Then this is the same as 1 over 4 x squared minus 1 squared plus c. Then this becomes your answer. So these two answers are the same, guys. The two answers are the same. I repeat, they are the same. Yeah. let's see if we can solve something again. Yeah, these questions are a lot. Alright. So yeah, we have another question here, which is sine squared of 3x multiplied by cos of 3x dx. So first thing first, can we simplify this? No. Can we, or do we have a function and its derivative? Yes, not really, but we can make it to be make sure by cooking the coefficient. Because of if we let, so let's rewrite this nicely. So if we let sine of cos of 3x dx. So if we let sine 3x to be our function, then the derivative of this has to be 3 cos of x, but then we don't have a 3, so we need to cook that 3. So I'm gonna put a 3 and then multiply by 1 over 3 so that I don't change the equation. So from here you can see that okay, I have a function and its derivative, so meaning that I can just apply general power rule also, because of my n here is not equals to -1, so I can be able to use general power rule. So the answer for this is just going to be 1 over 3 and then sine 3x to the power of 2 plus 1, that's your 3, divided by 3 plus c, and then you multiply it out there, that's going to be 1 over 9 sine cube of 3x plus 3. So then this becomes your answer. Yeah, I hope you got it. That was easy. Easiest question ever. So now we have integral of dx divided by a root of 1 minus x. So first question first, can we simplify this? No. Do we have a function and its derivative? Yes. So if we let 1 minus x to be your what? Your f of x, the derivative of this has to be -1, but then we don't have -1, we have +1 here. So we know that we can always cook the numbers as well as the signs, so we can cook -1 here. So let's first rewrite this in a nice way so that you don't get confused. So this is 1 minus x to the power -half dx. So we say that we're going to let this to be our f of x, and then the derivative of this has to be -1. So because of I didn't have a -1 in my equation, so I introduce another -1 outside there, so that this and this, when they multiply out, we go back to what our equation was given as. So from here, since we have the function and the derivative of that function, then we can be able to use general power rule. Also, our n here is not equals to -1, so we can use the general power rule. So the answer for this is just going to be the -1, which was coming from there, and then 1 minus x to the power -half plus 1, that's your +half, divided by half plus c. Then of course we can rewrite this nicely by taking the 2 up. That's going to be -2 multiplied by the root of 1 minus x plus c. So then that becomes your answer. So I hope you got it, because this is easy, right? It's now easy. It's now very easy. So we have another one here. So let's go. Okay, we now have integral of this. So let's first start by rewriting this in a nice way so that we avoid or we minimize mistakes. So this is 2 minus t to the power 2 over 3 dt. So now we check, can we simplify this? Now we can't. But then, do we have a function and its derivative? So we check. So if we let 2 minus t to be our function, what is the derivative of this? It's minus 1, but then we don't have minus 1 here. So we can always cook the numbers, remember? So I cook the derivative of it. So I cook it without changing the equation. So I multiply by minus 1 again so that I don't change the equation. So now you can be able to use to integrate this using a general power rule. So minus 1 and minus 1 multiply together 1. So yeah, but then we make use of minus 1 and this so that we apply our general power rule. Since we have the function and its derivative, we can apply our general power rule. So the answer for this is going to be this minus 1, which is coming from the outside, and then you apply your general power rule. So 2 over 3 plus 1, that's your what? That's your 5 over 3, right? That's your 5 over 3. So 1 plus 2 over 3, that's your 5 over 3 divided by your 5 over 3 plus c. Then of course we can again rewrite this in simple terms by saying this. So we'll take the 3 up there, that's going to be minus 3 over 5 multiplied by, and then we change this to a cubed root. So this is going to be multiplied by the cubed root of 2 minus t to the power of 5 plus c. And then this then becomes your answer. And then we continue. We don't stop. We don't stop. We continue. We check another one first. So we check this one out. So when we check this one, we have integral of sine 2x divided by cos squared of 2x and then dx. So we check, can we simplify this? Now we cannot simplify this, right? We cannot, we can, but I don't know. So we can do this in 2 ways. We can either do it by simplifying first. So if we simplify this, we're gonna have this. So yes, we can simplify this. We can simplify this. So we can use 2 methods basically. So this can be what? So we can say sine of 2x divided by cos of 2x multiplied by 1 over cos of 2x dx, right? So sine x divided by cos of 2x, what is it? It's your tan of 2x multiplied by 1 over cos. When we use our reciprocals, what is it? It's our sec, right? So this is our sec of 2x dx. So now we have tan of 2x sec of 2x. We ask ourselves, what is it that was derivated for us to get tan x sec 2x? So we know that it was a sec. Whenever we derivate a sec, we get what? Sec x tan x. So from here but then the only missing thing is the derivative of the angle. So the only missing part it's 1 over, no, it's 2. It's 2 and then 1 over 2 outside there. So we know that sec of 2x was derivated for us to get tan of 2x, sec of 2x multiplied by this 2 here, and then 2 and 2 they cancel out so that we don't change the equation. So now when we answer this, we can simply say this is 1 over 2 sec of what? Sec of 2x plus c. So yeah, this then becomes our answer. Okay, another person could have went with this form. So let me just write the other method. So one could have first rewritten this. One could have first rewritten the integral in this format and say this is sine of 2x multiplied by cos of what? Of 2x to the power minus 2 the x. So if we let cos of 2x to be our function, can this be the derivative of that one? Yes, but we need to cook it so that it becomes fully the derivative of that. So when we derivate cos of 2x, it must be negative 2 sine 2x. So here that means we must multiply it by negative 2, negative 1 over 2, so that we don't change the equation. So now that means we can make use of minus 2 sine 2x multiplied by that, and then we apply general power rule. Also because of our n is not equals to negative 1, so we can be able to use general power rule. So the answer for this was then going to be equals to negative 1 over 2, which is the one that I had outside the integral. Then I apply general power rule there. That's going to be cos of 2x to the power of negative 2 plus 1, that's negative 1, and then divided by negative 1 plus c. Then I will definitely get, so negative and negative, they're going to cancel out, and then we're going to get 1 over 2. Then we rewrite this in terms of positive exponent. We're going to get 1 over cos of 2x plus c. Then from there, this is going to be, so 1 over cos, when we use the reciprocals, that's going to be 1 over 2, and it's your sec of 2x plus c. So that's your sec of 2x plus c. So you see, these things are the same, whether we use general power rule or simplifying first is the same thing. Then yeah, I hope you got that one. Let's quickly check if we can solve another one, and then we solve from there. We don't waste time, we are going to solve it. So by now, I believe that now you have gained so much confidence in these things, you can solve a lot of questions from now. So we check this thing as well. So we ask ourselves, can we simplify this? No, we cannot be able to simplify this. Or maybe we can, but that's a long way to freedom. We just need to ask ourselves another question. Do we have a function and its derivative? Then we check. We have tan there. When we derivate tan, we get sec squared. So meaning that yes, we do have a function and its derivative. So meaning that we can now use general power rule. But then before we use it, let me rewrite this question nicely so that you are not confused. I don't want to confuse you. So this is going to be this. So you check. If we let tan x to be our function, then Is sec squared of x the derivative of that? Yes. So meaning that we can just apply general power rule. Also, our n is not equals to -1, so we can use general power rule, of course. So when we apply our general power rule, that's just going to be tan of x to the power 3/2 plus 1. 3/2 plus 1, that's your what? 3/2 plus 1. So 3/2 plus 1, that's your 5/2, right? So this is your 5/2 divided by divided by 5/2, I'm sorry for that, plus c. Then of course we can rewrite this nicely. That's your 2/5 and then square root of tan to the power 5, right? Then we can write this using a square root, so that's going to be tan to the power 5 of x. Yeah, that is the thing. So plus c, let's not forget plus c. And then yeah, this is it. That was it for a question. That was it. So I hope you got it. And then from here we move to these ones. So we have another one here, so let's quickly solve this one and then we'll see what to do from there. So we have the integral of 1 minus x to the power n dx. So we ask ourselves, can we simplify this? Definitely no. Can we? Because we cannot be able to expand. Or we can, but can we? I know we cannot. We cannot be able to expand because of, and we cannot. So yeah, so what are we gonna do from there? If we cannot be able to simplify, then we should move to the second question, which says that we ask ourselves that, do we have a function and its derivative? So you check if you let 1 minus x to be your f of x or your function. So outside there, do we have the derivative of it? So 1 minus x, when we derivative it is equals to -1. So it is equivalent to -1. So with respect to x, so that means I need to put -1 outside there. But then I should not change the equation. I should again multiply by -1 outside there. So that -1 and -1, they take us back to +1 there. So yeah. So without wasting time, we ask ourselves again, now, do we have a function and its derivative? Of course we do, because if we let 1 minus x to be the function, the derivative of it is -1, which we already have here. So we can make use of that and then use general power rule. So the answer for this is just going to be equals to -1, which is coming from the outside there. Then I apply general power rule. That's going to be 1 minus x to the power n plus 1 divided by n plus 1 plus c. So that then becomes your answer. So I hope you got it. That was an easy one, right? It was an easy one. So let's quickly see if we can solve another one. Remember to pause the video so that you can work out on these problems on your own and then resume later to check the memo, of course. So now we have the integral of cos of 3x divided by sine squared of 3x dx. So we check, can we simplify this first? Can we simplify this? So we check, if we simplify this, we're going to get tan x. We're going to get cos 3x divided by sine 3x multiplied by 1 over sine x. So okay, So okay, so cos x divided by sine 3x multiplied by 1 over sine 3x. So yes, we can be able to simplify this that's what I'm trying to say. In simple terms, we can be able to simplify this. So let's see, if when we simplify this, this is going to be cos of 3x divided by sine of 3x multiplied by 1 over sine 3x dx, just like that. And then from here, we can simplify this again. So cos divided by sine, what is it? It's our cot, right? So this is cot of 3x. And then 1 over sine x, what is it? So when we use the reciprocal, 1 over sine 3x, it becomes cosec, right? It becomes cosec of 3x. It becomes cosec of 3x dx. So then now we ask ourselves, what was derivated, I mean, for us to be able to get an answer of cosec. So we know that one, it's famous, right? It's very famous, that one. It's the one of cosec, right? So it was cosec that was derivated for us to be able to get that. But then this is not complete, because of we're supposed to get it as negative. So we're supposed to get, whenever we derivate cosec, we get negative cosec cot, I mean. So again, so this was supposed to be, we're supposed to have negative 3 here, and then but just because of we didn't have that negative outside here, so I have to multiply this by negative 1 over 3 so that I don't change the equation. So we know that the thing that was derivated for us to get negative 3 cot of 3x cosec of 3x was what? Was cosec of 3x. So when we answer this now, we can just say this is minus 1 over 3 cosec of 3x, and then plus c. So yeah, that's it. Of course, one of you could have said, nah, I can just use what is this? I can just make use of general power rule, because of I'm getting tricked when I use use the method of simplifying first. So if you want to use general power rule, it can also work. So that's going to be cos of 3x, and then sine of 3x to the power of negative 2 dx. So yeah, remember guys, we always let something that is equal, that is inside the bracket, to be our f of x. So when you are doing your things there, you want to use general power rule, always remember that the thing that is inside the bracket is you tend to use it as your f of x. So if we let sine 3x to be our f of x, then what is the derivative of sine 3x of sine 3x? Yes, of course, it's 3 cos of 3x, right? So but then outside there we do have cos of 3x, we just don't have a 3, so we need to cook that 3 so that this becomes fully our derivative of sine 3x. Then from there we can see that 3 cos 3x is the derivative of this, so we can use our general power rule. So the answer for this is just going to be 1 over 3 multiplied by sine of 3x to the power minus 2 plus 1, that's your minus 1 divided by minus 1 plus c. Then from here, our thing can be rewritten as minus 1 over 3 divided by 1 over sine of 3x plus c. But then 1 over sine of 3x can be rewritten using the reciprocals, and then that's 1 over sine, it's the reciprocal of cosec of 3x, and then plus c. So you can say that the two things are the same. So it depends on the one that you prefer. So you're going to go with the one that you prefer the most. So yeah, that's it. I hope you got the two other ones. Yeah, let's continue. So we have other questions here for definite integrals, whereby we're supposed to evaluate them. So let's start. So 2.1, we've got the integral of 3x squared minus 2x plus 1 dx, limits being from -1 until 3. So let's integrate. So when we check our integrand there, we don't need to simplify. It is simple, so we can just integrate from there directly. So the answer for this is going to be just 3x cubed divided by 3 minus what? Minus 2x squared divided by 2 plus x, and then your limits being 3 and minus 1. Then we substitute our limits there. We substitute our limits, then it is going to be 3 cubed minus 3 squared plus 3 minus into, then we put the one of minus 1 cubed minus 1 squared plus into minus 1. Then we use our calculator, we press there. So 3 cubed minus 3 squared plus 3 minus into what? Minus 1 cube minus 1 cube minus into minus 1 squared minus 1. Then you should be able to get something like 24 on your calculator there. So yeah, the answer is gonna be 24. And then that's it. Then we again let's try to solve another one quickly. So the other question could be so we have the integral of x divided by 2x squared plus 1 cubed dx, limits being from 0 to 1. So let's integrate. So when we check our integrand there, we can we simplify it? No. Do we have the function and its derivative? Yes, but we need to cook the coefficients first, because of if we let this to be our function, then the derivative of this has to be 4x, right? So but then we only have x there, so we should cook 4. So meaning that we need to first rewrite this in this form, 1 0, and then my x, and then 2x squared plus 1 to the power of minus 3 dx. I will say that we are going to let 2x squared plus 1 to be our function, or our f of x. So when we derive this, we are getting 4x, but then we don't have 4x, they will only have x. So we're going to cook the 4, and then we don't change the equation, we again multiply by 1 over 4, so that we still have the same equation that we were given. Then from here, we are going to use general power rule, because of we have the function and its derivative. So this is going to be 1 over 4 from outside, and then multiplied by 2x squared plus 1 to the power of minus 2 divided by minus 2, and then we put the limits 1 and 0. Then we can just now substitute our limits there. This is going to be minus 1 over 8, and then we substitute, okay, this is 1 and then 2, or where there is x, we substitute our upper limit first, is going to be x squared plus 1 squared minus what? 1 over 8 multiplied by 1 over 2x into 0 plus 1 plus 1 to the power of 2. Then we close. We use our calculator there. This is going to be, oh, I left the minus here. I left the minus here. So yeah, this is going to be minus, so I'm using my calculator right now to press. So just a second. 2 into 1 squared plus 1 squared minus into minus 1 divided by 8 into 2 into 0 squared. So I even forgot the squared there. Plus 1 squared. And then I close. So this should give you a 1 over 9 on your calculator. So yeah, that's your answer for this definite integral. And then we move. We go to the following one, which is this one. So let's integrate it quickly and see what's going to be our answer. So we're given that x squared minus 2x to the power 4, the x inside the root, then we should integrate it. So can we simplify this? So because that's always the first question that we need to ask ourselves before we integrate. So can we? Yes, we can. How are we going to do that? We can do it in this format. So this is going to be 1 over 2, 0. So we're going to take x squared as the common factor there inside the root. So this is going to be x squared into 1 minus 2x squared. And then the x there. Then the x. And then from there, we are going to make this term and that term to have its own root. To have its own root. So meaning that will end up having something like, so square root of x squared is just going to be x, and then the square root of the other one will still be the square root of the other one. So one more thing, I'm going to change that root to an exponent. That means I will end up having 1 minus 2x squared to the power of 1 over 2. So first thing first, I made this term to have its own root and that the root, and this one to have its own root. Then they multiplied each other. Root of x squared became x. Root of that became root of 1 minus 2x squared. Then I changed it to an exponent form. Then it became that. Then from here, we can see that if we let 1 minus 2x squared to be the function, then the derivative of it must be negative 4x. So when we derivate this with respect to x, we are going to get negative 4x. But then we don't have negative 4x there, so that we can be able to use our general power rule. So meaning that I must cook my negative 4 here, and then cook my negative 4 outside. So I'm going to multiply by 1 over negative 4, so that negative 4 and negative 4 cancel out, and then I will still be having the same equation. But then I can make use of negative 4x multiplied by 1 over 2x squared to the power 1 over 2 dx. So if this is my function, then and also this is my derivative of that function, then that means I can be able to use general power rule. Also, my n is not equals to negative 1, so yeah, I'm allowed to use that. So the answer for this is going to be negative 1 over 4, which is coming from the outside there. Then now I apply my general power rule. Is going to be 1 over 1 minus 2x squared to the power 1 over 2 plus that's going to be 3 over 2. 1 over 2 plus 1 is 3 over 2. Then divide that by 3 over 2, and then I put my limits 1 over 2 and 0. Then from there, I need to substitute my limits. So I substitute my limit here. I'm going to get negative 2. Okay, so it's going to be, so 2 will go up there. So it will be 2 over 4 times 3. 4 times 3, it's 12. So it's going to be 2 over 12. So 2 over 12, that's 1 over 6. So this is going to be minus 1 over 6. And then there I can just substitute my limits. 2 into 1 over 2 squared to the power 3 over 2. Like that. And then minus, I substitute again, minus 1 over 6 multiplied by 1 minus 2 into 0 to the power 2 all to the power what? 3 over 2. Then from here, I need to then use my calculator. So you're going to then use your calculator from here, sorry. So it's going to be minus 1 over 6 multiplied by 1 minus 2 into 0.5 squared. Then you close, you say to the power 3, everything to the power 3 over 2. And then you say minus that's going to be a plus, and then 1 over 6 you say multiplied by 1. You should be able to get something like 0,108. So when you press on your calculator, you should be able to get something like 0,108. So yeah, I hope you got it. It's an easy one. So we have another one here. Let's quickly solve it. So we now have we now have integral of x multiplied by the root of 2x squared minus 1 dx. So we can see that we cannot be able to simplify this, because of even if we can say we want to multiply, it won't be possible. So we need to use the second question. So we'll ask ourselves, do we have a function and its derivative? So we check if we let 2x squared minus 1 to be the function, can x be the derivative of it? So we check that the derivative of 2x squared minus 1 with respect to x is going to be 4x. But then we don't have a 4 there, constant 4, or a coefficient of 4. We don't have a 4 there, so we need to cook that 4. So I can rewrite this nicely by saying that I have my limits here, 3, 0. 4x, I cook my 4 out there, and then 2x squared minus 1 to the power of half dx. Then from here, you can see that the 4 and 4 can cancel out, so meaning that I didn't change the equation, I still have the same equation. But then I can make use of 4x multiplied by 2x squared minus 1 to the power of half dx. So from here, since I have the function and the derivative of the function, I can be able to use general power rule, like I've said. And then also my n is not equals to -1, so yes, I'm allowed to use general power rule. Therefore the answer for this is just going to be equals to 1 over 4, which is coming from the outside there. Then I apply my general power rule, which is just going to be 2x squared minus 1. I add 1 on the half there. I get what? 3 over 2. Then I divide this by 3 over 2. I put my limits, which are 3 from 0 to 3. Then I now substitute my limits. So when I substitute my limits, I get that this is the same as 1 over 6, right? So this is the same as 1 over 6 because of I am going to take 2 up there, and then 4 and 3, they multiply each other. So I'm going to have 2 over 12, that's 1 over 6. So this is 1 over 6, and then I substitute my limits. 2 into what? Into 3, which is the upper limit. Remember, we always start with the upper limit. all to the power 3 over 2 minus, and then I substitute again 1 over 6 multiplied by 2 into 0 squared minus 1 to the power of 3 over 2. Then I close there. I close. Then I then use my calculator from here. I'm gonna use my calculator, so let me punch quickly. So this is 1 over 6 multiplied by 2 into 3 cube into 3 cube minus 1 everything to the power 3 over 2 minus 1 over 6 multiplied by minus 1 to the power 3 over 2. Then you are going to use your calculator there. You should be able to get what? You should be able to get something like 2. So I'm still punching, just a sec. Yeah, then this one is going to be undefined when you punch on your calculator because of negative 1 to the power 3 over 2 is undefined. So it's going to make this whole thing to be undefined. So this is undefined when we punch on our calculator. Then we continue, we try to solve our equations. Then from here we can see that the integral of x plus 1 divided by the square root of that is okay. So we are going to first ask ourselves, can we simplify this? Then we find that no, we cannot be able to simplify this. Then we are going to use the other question. So the other question says that we should ask ourselves that do we have the function and its derivative. Then we check if we let x squared plus 2x plus 4 to be the function, then what is the derivative of it? It's 2x plus 2, but then there we have x plus 1, meaning that we need to cook this. So we need to cook the 2 there. So before we cook, let's rewrite it like this first. So this is going to be 1 0 and then x plus 1, and then another thing here we have x squared plus 2x plus 4 all to the power of negative half dx. Then from here you can see that if we let this to be the function or to be f of x, then the derivative of this is 2x plus 2, which is what we're supposed to have here, but we don't really have it. We are missing the only thing that is missing here is the 2, so meaning that we should cook the 2 here so that this becomes fully the derivative of that thing. But then 2 was not there, so we need to multiply by 1 over 2 so that we don't change the equation. Sorry. Then from here we can see that we can make use of this and that by using general power rule to integrate it. So since we have the function and its derivative, then we are allowed to use general power rule. So this is going to be 1 over 2, which is coming from there. Then we say now I apply my general power rule. This is going to be x squared plus 2x plus 4 to the power of negative 2 plus 1. Negative 1 over 2 plus 1, that's positive half, divided by half there. Then we put my limits, 1 is to 0. Then from here, I can say that 2 and a half will multiply each other to form a 1. Then at the end of the day, when I substitute my limits, I'm gonna get the following. So this is going to be 1 squared plus 2 into 1 plus 4 minus into, I substitute the 1 of 0. So this is going to be 0 squared plus 2 into 0 plus 4. Then from here, I need to punch on my calculator. So that's going to be the square root of 1 squared plus 2 into 1 plus 4. And then minus the square root of that's just the square root of 4. Then I should be able to get something like 0,646. So this is supposed to be your answer for that question. So I hope you got it there as well. I'm hoping so. And then from here, let's try to solve another question quickly. So this is going to be what? So we now have the integral of 1 minus x cubed all to the power of 2 dx. So we're going to do what? So first ask ourselves, can we simplify this? Then yes, we can. Then we go and simplify first. So this is going to be 2, 1, and then we simplify by multiplying out there. That's going to be 1 plus 2x cubed plus x to the power of 6 dx. Then now we can integrate this because it's simple. So with respect to x, when we integrate that, that's going to be x plus 2 x to the power of 4 divided by 4 plus x to the power of 7 divided by 7. We put our limits 2 and 1. Then we substitute the limits from there. So this is going to be 2 plus 2 or plus 1 over 2. And then I put my 2 to the power of 4 plus 1 over 7. I put my limit 2 to the power of 7 minus minus what? Minus I substitute the other limit, so it's going to be 1 plus 1 over 2 into 1 to the power of 4 plus 1 over 7 to the power into 1 to the power of 7j, just like that. Then you use your calculator. Let me press quickly. This is going to be 2 plus 1 over 2, 1 over 2 multiplied by 2 to the power of 4 plus 1 over 7 multiplied by 2 to the power of 7 minus 1 minus 0 or plus 0.5, I mean. Minus into 1 plus 0.5 plus 1 over 7. And there we should be able to get something like 26 comma. Your answer should be 26,643. So yeah, this is going to be your answer for that one. Then from there, we are going to solve the following one. So yeah, let's quickly solve this one. So yeah, feel free to pause the video so that you can work out on this problem on your own and then resume later to check the memo, of course. So this one, we can say that the first thing that we need to do, we ask ourselves, can we simplify this? No, it's not necessary, but Okay, then we ask ourselves the following question. Do we have the function and its derivative? Yes, we do. What's the function? It's tan of x. So meaning that we are going to use general power rule. I can rewrite this nicely to show it like in this format and say this is my tan of x to the power of 1 multiplied by sec squared of x dx, just like that. So we can say that tan x, if we let it to be our f of x, then its derivative is sec squared. Okay, so from here we can use general power rule because we already have the function and its derivative. So we can just use general power rule and say this is the same as tan of x to the power of 2 divided by 2. I put my limits pi over 4 and 0. Then I substitute my limits. There it's going to be 1 over 2 tan pi over 4 squared minus 1 over 2 tan of 0 squared. Then you should put your calculator in radians. Then that's after putting it in radians, then you can then substitute your things to get the answer. So I'm calculating now. I'm punching on my calculator to get our answer. This is going to be what? 1 over 2. So I get 1 over 2 on our calculator. Yeah, so yeah, that's going to be the answer for that question. I hope you got it as well. Yo, someone is sick. Eh? Someone must see the doctor. The doctor. All right, this one. So we're going to ask ourselves that can we simplify this? Then yes, we can. Then let's go and simplify first. So when we simplify this, I'm going to rewrite. Then this is going to be x minus 3 dx. Then the integral of this is the same as okay, then x minus 3 and x minus 3 are the same, so I can say this is x minus 3 squared, then dx. Then from here we need to take the absolute of x minus 3 because of because on the interval of the limits, the 0 is to 1, what x minus 3 is less than 0. Therefore we need to take so therefore what I'm trying to say is that we need to say we need to take the absolute value of x minus 3 there. So this is going to be equals to 3 minus x, because of the absolute value always gives the positive number. So we need to take the positive one there because of on the interval x minus 3 itself is less than 0. You understand? So I hope you understand this trick. Because of instead so here I'm not gonna take x minus 3. That's what I'm trying to say. Because of at 0 is to 1, this x minus 3 is less than 0. So we're not gonna take that. We're gonna use the absolute value and then take 3 minus x. So at the end of the day here, my integral is equals to 3 minus x, 1 is to 0, then dx. Then from here I'm going to integrate. This is going to be equals to 3x minus x squared over 2, 1 is to 0. Then you put your limits there. This is 3, into 1 minus 1 squared over 2 minus 3 into 0 minus 0 squared over 2. You will get that your answer for this one when you punch on your calculator is going to be 3 minus 1 over 2. 3 minus 1 over 2, that's your 5, positive 5 over 2. So yeah, this is going to be positive 5 over 2. So yeah, I hope you got it. The only tricky thing that was that you had to take the absolute value for this one instead of taking it as x minus 3. So yeah, you had to take the absolute value for that one. Then we find that we should continue and solve other questions. We're not done yet. So for this one, when we integrate this one, this is going to be, so the first question first, can we simplify this? Yes, we simplify first. So let's start by simplifying because of it's gonna be the simple way. So when we simplify this is going to be x multiplied by 1 minus 2 x to the power half, or 2 root of x. 2 root of x. So root of x, I'm going to write it as that, plus x, then dx. Then I multiply everything by x there. That's going to be x minus 2 x to the power 3 over 2 plus x squared. Then what? Dx. Then from here we can say that we can be able to integrate. This is x squared over 2 minus 2x to the power 3 over 2 plus 1. So 3 over 2 plus 1, that's your 5 over 2. So this is your 5 over 2 divided by 5 over 2 plus x cubed over 3. You put your limits, 1 is to 0. Then you substitute the limits here. This is going to be 1 squared over 2 minus 4 over 5. 4 over 5, x being 1, and then 5 over 2 plus 1 over 3. So here we're going to say 1 over 3 cube. Yeah, 1 cube over 3, I mean. Then we substitute the 0, 0 squared over 2 minus 4 over 5 into 0 to the power 5 over 2 plus 0 cube over 3. And then you substitute there, you punch on your calculator. Then this is going to be 0.5 minus 4 over 5 plus 1 over 3. Then I get my answer as 0,033, which is the same as 1 over 30. So yeah, this is the same as 1 over 30. Okay. Then from here we need to do other questions quickly, as quick. Yeah, someone must see the doctor. So yeah, we have another one here, which is sin x divided by 1 plus cos x all to the power of 2 dx. Then we should integrate this. First thing first, can we simplify this? No. Do we have the function and its derivative? Yes, but then we need to rewrite it nicely first so that we can see what is happening. So this is going to be sine of x multiplied by 1 plus cos of x to the power of negative 2 dx. So if we let 1 plus cos of x to be our f of x or our function, then can this be the derivative? Yes, but then it's incomplete because the derivative of 1 plus cos x is going to be minus cos x. So we don't have minus sine x. So we don't have minus. So the derivative of this is minus sine x. So we don't have the minus, which I've just put here. But then since we didn't have this minus, we should again put the minus there outside there so that we don't change the equation. Then from here, we make use of this derivative of that function and then use general power rule to do that. So this is going to be minus, which is this one coming from the outside, minus 1 multiplied by 1 plus cos of x to the power of negative 1 divided by negative 1 multiplied by, oh, it's fine. Then we say plus c. Then we can see that negative 1 and negative 1 will chop each other. So I can just simply remove them just like that. And then I can just, okay, it's fine. Even if I can put them and then I can just rewrite. Oh, this is, now I'm confused. Now, am I tired? I think I'm tired. So we need to put the limits. Why did I write plus c? I think I'm tired or I'm drunk. One of the two. Which one is which one? I think the drunk one must be correct. Okay. Then from here, we can see negative 1 and negative 1 will cancel out. If we were to write this with positive exponent, we're just going to take this whole thing down there. So it's going to be 1 over 1 plus cos of x. Just like that. So we need to put the limits from here, so meaning that this is going to be 1 over 1 plus cos of pi over 3. So pi over 3 minus 1 over 1 plus cos of 0. So yeah, okay. Then you are going to use your calculator. Remember, your calculator should be in radians in this case. So it's going to be 1 plus cos of shift pi over 3. I'm punching on my calculator here. You should do the same. And then 1 plus cos of 0. What I'm going to get, it's simply a 1 over 6. So the answer for this is going to be 1 over 6. So yeah, that's it. That's what you're supposed to do for that question. And then we move. So this one, we now have the integral of tan inverse of x divided by 1 plus x squared dx. So you ask yourself, can I simplify this? No. Can you, do you have the integral? Do you have the function and its derivative? That's what I'm trying to say. So do you have the function and its derivative? You check. Yes, you do, because you have tan inverse of x, and the derivative of tan of inverse of x is 1 plus x squared. So meaning that I can just rewrite this nicely so that you don't get confused. So this is tan inverse. So this is tan inverse of x all to the power of, so this is to the power of what? 1 multiplied by 1 divided by 1 plus x squared dx. So we have the function and its derivative. What does it mean? It means that we can use general power rule, right? So we then apply our general power rule. This is going to be the tan inverse of x to the power of 2 all divided by 2. I put my limit, 1 is to 0. Then I substitute my limit there. This is going to be 1 over 2 multiplied by tan inverse of what? Of 1. I'm substituting my limit right now. Then squared minus 1 over 2. I substitute my limits again. Tan inverse of 0 squared. then I should be able to get something like a what? So 0.5 multiplied by the tan inverse of 1. You square that minus 0.5 tan inverse of 0. You square that. You will get something like 1 comma, I'm getting 1 comma 3, 1,213. I'm getting 1,213. So that has to be your answer for that one. Okay, wait guys, let me just validate my answer. I think I might have punched wrong things on my calculator, so just a second. Multiplied by tan inverse, oh shift, 0,5 into tan shift, shift tan inverse of 1 squared minus 0,5 into tan shift tan inverse of 0 squared. Yeah, so this is wrong. What I was doing in my calculator, I was not pressing tan inverse, I was pressing tan instead of tan inverse. So yeah, I realized the mistake quickly. So this is 0,308, 0,308. So this is supposed to be the answer for that question. Yeah, 0,308. So yeah, I was doing the mistake of patching tan instead of tan inverse on my calculator. So yeah, the answer is supposed to be 0,308. So yeah, I hope you got it as well. Okay, we have another question here that we need to solve. So integral of cos cube of x sine x dx. So we need to integrate this. What we need to ask ourselves first is that, can we simplify this? Then it's a no for this. Do we have a function and its derivative? Yes, we do. So I can just first rewrite this nicely by saying pi 0. I write cos of x cube multiplied by sine of x, then dx, like that. And then from here, if you let cos x to be your what, your f of x or your function, then this must be the derivative of that. But then it's not complete, because of whenever we differentiate cos, we get negative sign. So I must put a negative here. So allow me to put a negative sign here. So again, I must cancel that negative sign. So I'm going to put -1 outside there. So from here, we are going to say, since we have the main function and the derivative of that function, then we can use general power rule. So this is going to be negative what? Negative cos of x to the power of 3 plus 1, that's going to the power of 4 divided by 4. And then you put the limits 0 and pi there. Then from here, you just need to substitute our what? We need to substitute our limits to get our answer. So -1/4 cos of pi to the power of 4 minus into -1/4 cos of what? Of 0 to the power of 4. Then you punch on your calculator. We should be able to get something like negative 1 over 4 multiplied by cos of pi to the power of 4 plus 1 over 4 multiplied by cos of 0 to the power of 4. So you will get that your answer is 0. So yeah, this must be your answer, 0. Then we need to solve more questions. We still have other questions to solve. So this is the other one. Remember to pause the video so that you can work out on this problem on your own and then resume later to check the memo, of course. So yeah, let's see. So now we have this one. When we check it, can we simplify this? No. Do we have the function and its derivative? Yes, we do, but then we need to do the cooking first. So let's rewrite this nicely first, and then we do the cooking. So I'm gonna take the 5 out and then write this as x squared plus 4 to the power negative half the x. Then we ask ourselves, if this is the main function, x squared plus 4, then is x the derivative of that? Yes, but it's incomplete because the derivative of x squared plus 4 is 2x, but then we don't have a 2 here, so we need to cook that 2. So I'm going to put the 2 and then put the 2 here so that the 2 and 2 cancel out, and then make use of what's inside there. So 2x multiplied by this, we can see that we have the function and its derivative. So what are we supposed to do here? We are supposed to use general power rule to differentiate that. So this is going to be the 5 over 2, which is coming from the outside, and then we apply general power rule there. That's x squared plus 4 to the power of negative 1 over 2 plus half. That's your positive half divided by half. And then you put the limits, 3 is to minus 1. Then 2 and 2 are going to, 2 and a half are going to cancel out, and then we'll only be left with 5. So I substitute my limits. This is going to be 5. And then I substitute the limits, 3 squared plus 4 all to the power of half minus, minus 5 into x squared. So x squared, it's going to be minus 1 squared plus 4 all to the power of half. Then you do this on your calculator, you just punch. So when you punch on your calculator, this is going to be square root of 3 squared plus 4 minus 5 square root of negative 1 squared plus 4. You should be able to get something like what? Like 5 square root of 13. 5 square root of 13. So 5 square root of 13 minus 5 square root of 5, which is the same as what? As 6 comma 847. So which is the same as 6 comma 847. So yeah, that was it for that one. It was easy, right? Okay, we have another one here that we need to solve quickly. So this is the other one that we need to solve. It looks tricky, but it's easy. It's easy, provided that we don't make a mistake. So we first ask ourselves, can we simplify this? No. Do we have the function and its derivative? Yes, but the derivative is incomplete, so we need to do the cooking of the coefficient. So let's rewrite this firstly in a nice way. So they are going to have 1 over x multiplied by the log of x to the power of 1 over 2 dx. So if we let this to be our f of x, and that be our, can that be our f prime of x? Can that be the derivative of this? Yes, but it's incomplete, so we need to do the cooking. When we derivate log of x, it becomes 1 over x ln of 10. So we are missing with ln of 10 is missing here. But then we didn't have this ln of 10, so that means I must put ln of 10 outside here so that it cancel out with that one that I've put. But then I can make use of this because of log of x, the derivative of it is 1 over x ln of 10, so meaning that I can use general power rule because now I have f of x and its derivative there. So the answer for this is just going to be ln of 10 multiplied by what? Multiplied by log of x to the power of 3 over 2, all divided by 3 over 2. I put my limits e and 1. Then from here I need to substitute my limits. So I'm going to get 2 ln of 10 divided by 3 multiplied by the log there. So it's going to be log of e to the power 3 over 2 all, okay, I've already changed that one, and then minus what? Minus 2 ln of 10 divided by 3 multiplied by the log of 1 to the power 3 over 2. So you punch that on your calculator, you should be able to get something like, okay, this is going to be a 0 because of log of 1 is 0. So you can just punch this only in the calculator. You should get 2 ln of 10 over 3 multiplied by ln, or log, I mean, multiplied by log of e to the power 3 over 2. So when you do that on your calculator, you will get something like log, I'm getting, so just a second, let me verify my mistakes. Ln of e log of 1. So this is going to be, okay, to the power 3 over 2. I'm getting 0.439. Yeah. So let's see if we can solve another one. So this is going to be yeah, I will go and see the doctor. I will go and see the doctor, Aish. I will go and see the doctor. Yeah, then from here, you are going to continue and integrate. So yeah, let's continue quickly and finish these few remaining questions. We've got few. So now we're given that the integral of x sine cube of x squared cos of x squared dx. Yeah, so we need to integrate. Can we simplify this? No. Do we have a function and its derivative? Yes, we do. So let me rewrite this nicely to show you that we really do. So this is square root of pi over 2, 0. And then we have x cos of x squared multiplied by sine of x squared all to the power of 3. So yes, we do have a function and its derivative, but then the derivative of the function is incomplete. We'll have to cook it. So if we let sine x squared to be the main function, or f of x, then can this be the derivative? Yes, but it's incomplete. When we derivate sine of x squared, we get 2x cos of x squared. So we get 2x cos of x squared. The only missing thing here is a 2. So we don't have a 2. So we need to cook a 2. But then we're not having that 2. So we need to multiply by 1 over 2. But then we can make use of the thing that's inside here, because of, since we have the derivative and its function, then we can use general power rule. So when we integrate this, is going to be the 1 over 2. The 1 over 2 is coming from outside. And then this is going to be sine of x squared all to the power of 4 divided by 4. Then you put your limits, square root of square root of pi over 2, and then 0. Then we substitute the limits. This is 1 over 8. So this is, now we substitute our limits. This is 1 over 8 multiplied by sine of square root. Okay. Square root of pi over 2 squared, we squared the angle there, to the power of 4 minus 1 over 8 minus 1 over 8 multiplied by sine of 0. Sine of 0 squared. So 0 squared to the power of 4. Yo, my mind sometimes get lost. Okay, we then need to just punch in our calculator. Sine of 0 is 0, so this whole thing is going to be 0. So we only need to punch this. So 1 over 8 multiplied by sine of what? Okay, pi over, let's just substitute pi over 2. Then we say to the power of 4. You should be able to get something like 1 over 8. 1 over 8. 1 over 8. But then let me just verify my steps so that we don't make a mistake, right? So that we avoid mistakes. So let me just say I'm verifying just a second. I'm verifying multiplied by, okay, sine of that. Okay, multiplied by okay, so I'm verifying with the calculator here if I didn't make a mistake. Just a second, be patient with me, be patient. Patience. So just a second, my calculator is still cooking. So yeah, Let's just see. We said we cook 2 and 2. Yeah, it is 1 over 8. Yeah, it is 1 over 8. Yeah, the calculator verified that. So yeah, 1 over 8 is the correct answer. So yeah, let's continue and solve the following one. So the following one that we have here is this one. So we have the integral of sine x plus 1, square root of sine x plus 1 multiplied by cos x dx. We should integrate. So can we simplify this? No. Do we have the function in its derivative? Yes. So let's rewrite it nicely. Before I like things that are written in a nice way, You know, when things are written in a nice way, it's easy to integrate. So sine x plus 1 to the power of half multiplied by cos of x dx. Then from here we need to integrate. So you can see that if we let sine x plus 1 to be our f of x, then cos of x is going to be the derivative of that. Yes, it's true. So meaning that since this is the derivative of that, then we can use general power rule. So our general power rule is just going to be sine x plus 1 to the power of half plus 1, that's a 3 over 2 divided by 3 over 2. You put your limit, pi over 2 is to 0. Then we substitute from there. So 2 over 3 multiplied by sine of pi over 2 plus 1 all to the power of 3 over 2 minus 2 over 3. You substitute again the lower limit. This is going to become sine of 0 plus what? Plus 1 to the power of 3 over 2. Then you substitute on your calculator, you punch there. Then that's going to be 2 over 3. I'm punching right now. I'm punching. So as I punch, you should be punching. Why did I write? Okay, this pi over 2 is correct. Pi over 2 plus 1 all to the power of 3 over 2 minus 2 over 3. Yeah, minus 2 over 3. You should be able to get something like 1,219. 1,219 when you use your calculator. Remember to put your calculator in radians, so you should be able to get 1,219, because sine of 0 is 0 and then plus 1 to the power, that is still that. So we can even substitute and say 3 over 2. This doesn't change. 1,219. So 2 over 3 into 2 square root of 2 minus 1. Yeah, 1,219 is your final answer for that question. So yeah, I hope you got it. Let's see if we can quickly solve another one here. It's over very in English if I can do. All right, so let's start. So this is going to be square root of x plus 2x squared dx. Then what? 2 minus 1. Okay, so now we should integrate square root of x plus 2 multiplied by x squared. So can we simplify this? No. Is the derivative, do we have a function and its derivative? no, then what are we supposed to do? We're supposed to go back there to change a variable. So meaning that this is one of the situations whereby we cannot dodge u substitution. So meaning that we should let our u to be equals to what? To be equals to x plus 2. Then we derivate this with respect to x. Our du is going to be equivalent to dx, just that. And then from there, from this u, we can make x the subset of the formula. So if we make x the subset of the formula, it is equals to u minus 2. X is just equivalent to u minus 2, just like that. So u, it is equivalent to, x is equals to u minus 2. So we can rewrite our given integral with respect to what? With respect to u. Another thing is that we can do, we also need to change our limits. So if we want to use the u's though in our limits, otherwise we need to substitute back our x's. I prefer substituting back our x's, but yeah, let me just show you how to also substitute this with respect to u. So our u there, so we need to change the limits if we want to change this. So because this is with respect to x, so now we want to write it with respect to u. So the upper limit there is going to be what? 2 plus 2. So we just use so we're just gonna use this. So since u is equals to x plus 2, we're gonna substitute that limit, and then we're gonna get our 4, and then the lower limit is going to be what? Minus 2 minus 1 plus 2, which is equivalent to positive 1. Then we can rewrite our limit now in this format. Of saying that okay, so root of x plus 2, it is root of u, or I can just say u to the power of half, and then I put my upper limit is going to be 4 is to 1. And then what about my x squared? So x squared, this is equals to u minus 2 squared. Then dx is equals to du. Then from here, I need to multiply out by first expanding the other one. So this is going to be u to the power of half multiplied by u squared minus 2 into 2u, that's going to be 4u plus 4 du. Then I multiply out again 4 half, that's going to be 2. So 2 plus half, 2 plus 0 0.5, that's your 5 over 2. So this is 5 over 2 minus 4u into to the power 3 over 2 plus 4u to the power of half. Then the u. Then from here we can see that now it will be easy for us to be able to integrate this. So we're just going to integrate from here. We're going to say u to the power of 5 over 2 plus half. So 5 over 2 plus 1, plus 1, that's equals to 7 over 2 divided by 7 over 2 minus 4 u 3 over 2 plus 1. So 3 over 2 plus 1, that's your 5 over 2 divided by 5 over 2 plus 4 u to the power of 3 over 2 divided by 3 over 2. You put your limits, 4 is to 1. So now we are going to what? To put our limits. So from there, so this is going to be what? 2 over 7 u, which is 4 to the power 7 over 2 minus 2 times 4, that's your 8 over 5. So this is 8 over 5. Your u, put the upper limit first, to the power of 5 over 2 plus 8 over 3 multiplied by my upper limit to the power 3 over 2 minus everything but changing the limit. So 2 over 7 multiplied by what? By 1 to the power of 7 over 2 minus 8 over 5. You put 1 now to the power of 5 over 2 plus 8 over 3 and then you put 1 to the power 3 over 2. Then you punch everything in your calculator now. You should be able to get something like what? So now I'm punching on my calculator 2 over 7. I put my 4. I put my 7 over 2 minus 8 over 5 into 4, then to the power 5 over 2 plus 8 over 3 now to the power of 4 to the power 3 over 2. Hey, what am I writing? 4 to the power of 3 over 2 minus 2 over 7 plus 8 over 5 and then plus 8 over 3 plus 8 over 3. Okay, this calculator is not allowing me to substitute 8 over 3. It's saying I've reached the limit. So let me just do this. Let me just punch separately. So this is, so for this one we get 704. So here I get 704 divided by 105. And then for the other part, I'm getting 2 over 7 plus 8 over 5 plus 8 over 3. Minus 8 over 3. This is going to be equals to minus 82. Minus 82 over 105. So at the end of the day, the total for this is 704 minus 82 divided by 105. This is 622. So it's going to be 622 over 105. But then let me verify first before I conclude. So let me verify if I didn't make a mistake. Yeah, so this is the same as what? So I'm verifying there on my calculator. If I'm writing 62. Okay, it seems like I made a mistake somewhere, either here or there. So let me verify. Let me repunch this on the calculator. I'm very sorry for that. 2 over 7 minus 8 over 5. Anyway, plus 8 over 5 plus 8 over 3. Okay. A minus, why am I saying this plus? Minus, oh, you're also minus. Oh, so this is minus 142. So I'm sorry, this was supposed to be minus 142 minus 142 there, so that 704 over 105 minus 142 divided by 105. So yeah, so that you can get 562 over 105. So yeah, yeah, the correct answer for here is this one. So yeah, that's it. One could have said that I don't want to use so if you didn't want to substitute using the u here, you could have still substituted using x, but the limits that you're supposed to use was going to be 2 and -1. So yeah, that's going to be that. Okay, I don't have to do that. You know how to substitute your u here back. So if your u is x plus 2, you're going to substitute x plus 2, but then the limit will be 2 and -1 there. So that's what I'm trying to say. What I'm trying to say, so that you don't get confused and say, oh, so let me just put the or here. Or you substitute your u there, it's x plus 2, that's your u. So it's going to be 7 over 2 divided by 7 over 2 minus 4. Your u is substitute as x plus 2 to the power 5 over 2, all divided by 5 over 2, plus 4u, which is x plus 2 to the power 3 over 2, all divided by 3 over 2. Then the limit, you're supposed to use 2 and -1 because of they are the ones for x. The limits for x are -1 and 2. So when you punch this, you should be able to get the same answer on your calculator as 562 over 105. So you can try it there, and then you'll see that is the same thing whether we use u or x's. Anyway, let's continue. We have another question there down here, which is this one. So yeah, let's go. So we have this one. So we can start by first rewriting this nicely, because of we can see that we don't have the function and its derivative, as well as we cannot simplify this. So that means we must use u substitution. So for us to be able to use substitution, let's first rewrite this nicely in this format. So 15, 3, and then x squared minus 9 to the power 1 over 3 multiplied by x squared multiplied by x dx. So I'm doing this because I can I can see what's going to happen when we let our u. So I don't want to go back. So now we can let our u to be equals to x squared minus 9. Then when we derive this, du is going to be equivalent to 2x dx. And then here, when we make x the subject of the x squared the subject of the formula, so x squared, it is equals to u plus 9. Then from here we can also rewrite our limits with respect to u. So u for the upper limit is going to be equals to 15 squared. So 15 squared minus 9 will get our upper limit. The lower limit is going to be 3 squared minus 9. So this is 0, and then that is how much? 15 squared. So 15 squared minus your 9, that's 260. 260. So that's with respect to u. So now we can rewrite our integral with respect to u. So the upper limit is going to be 216, 0. Then x squared minus 9, it is equals to u. So that's u to the power of 1 over 3, and then x squared itself, it is equivalent to u plus 9. Then x dx, so if we can make x dx here, we are going to get du over 2. So this is du over 2. That makes sense, right? So we just need to take 1 over 2 out. So when I take 1 over 2 out, I'll get 2160, and then I multiply there, I'll get u to the power 1 over 3 plus 1. 1 over 3 plus 1, that's about 4 over 3. 4 over 3 plus 9u to the power of 1 over 3. Then we integrate this with respect to u. Then from here, you can see that it's going to be easy to integrate. This is just going to be 1 over 2 multiplied by what? U to the power 4 over 3 plus 1. So 4 over 3. So 4 over 3 plus 1, that's about 7 over 3. 7 over 3 divided by 7 over 3 plus this 9 multiplied by u. 1 over 3 plus 1. 1 over 3 plus 1, that's about 4 over 3. So that's 4 over 3. So all of this divided by 4 over 3. Put your limits, 216 and 0. Then we're just going to substitute from here. We're going to get that 1 over 2. I substitute everything there, 216 to the power of 7 over 3 divided by what? By 7 over 3. 7 over 3 plus 9 into 216. So I'm just substituting the upper limit divided by 4 over 3 here, and then minus 1 over 2. You substitute that, you substitute 0 and 0, so that's going to be 0 to the power 7 over 3. 7 over 3 plus 9 into what? 0. 4 over 3 over 4 over 3. Everything in the bracket will be 0. So we just need to punch this other side only. So it's going to be 0.5 multiplied by 216 to the power of 7 over 3 divided by 7 over 3 plus 9. Okay, 9 what? Our u being 216 to the power of 4 over 3 divided by 4 over 3. You do that on your calculator, you should be able to get something like let me just verify my answers. So I'm getting, okay, 7 over 3, 9, okay, 4 over 3, 4 over 3, 7 over 3, 216, 7 over 3, 0.5. Okay, I'm getting 450, 450, 522 over 7. That's about it's approximately equals to 64360,286. So just let me just verify this using what? Let me just verify this using the calculator. So let me punch this on the calculator. This is going to be okay, 1 over 2 multiplied by multiplied by the integral of that. So I'm just substituting on the calculator, guys. Be patient with me. I'm just putting this in the calculator. 4/3 plus 9 to 9 what? 9 to the power of 1/3. Then I close, put my things 0, 216. So yeah, just a second guys, I'm verifying this on the calculator. So yeah, this is correct. So let's continue and solve the 3 last questions. So we have this question. Pi/2, 0. And then, okay, first thing first, can we simplify this? No. Do we have a function and its derivative? Yes, we do. So I'm rewriting this nicely so that you can see that we really do have the function and its derivative, cos of x dx. So if we let sin x to be our f of x, then cos of x is going to be our f prime of x. So we can then use general power rule and say the answer for this is sine of x to the power of 6 divided by 6 there. And then we put our limits pi/2 and 0. Then we can substitute our limits there, starting with the upper limit. This is going to be sine of pi/2 to the power of 6, or to the power of 6 minus the 1 of 0. So it's going to be sine of 0 to the power of 6/2. Sine of 0 is 0, so we're just going to substitute the first part only on our calculator. Then it should give us something like pi/2 to the power of 6. We should get something like a 1/6 on our calculator. So I hope you understand that one. It's easy, right? So this is our second last question. So yeah, let's go. Can we simplify this? No. Do we have a function and its derivative? Yes, but then it's not written nicely. So let's rewrite this in a nice way. 1, 0, and then x, and then what? 2x² plus 1 to the power of -3 dx. So what's going to happen here is that if we let 2x² plus 1 to be our f of x, then can this be our f prime of x? Yes, but it's incomplete because of when we derivate 2x² plus 1, we get 4x. So there is a missing 4 here. So since we have put that 4, we need to cancel it out by -1/4 so that we don't cancel our question. But then we can make use of 4x multiplied by that. So we can just use general power rule to integrate that. So this is 1/4. We apply general power rule. This is going to be 2x² plus 1 minus 3 plus 1. That's -2 divided by -2. We put our limits. 1 is to 0. We substitute our limits now. This is going to be -1/8. I mean -1/8 because of 4 and 2 will multiply each other, multiplied by 1/2. Okay, 2 into, we substitute our limits, squared plus 1, and then squared minus into -1/8 multiplied by 1/2 into 0 squared plus 1, everything squared. Then we substitute this in our calculator to see what the answer is going to be. So I punch everything there. I find that -1 over 8 multiplied by 2 plus 1 squared plus 1 over 8 multiplied by 2 into, okay, so it's 2 into 1, okay? 2 into 1 plus 1, okay, so it's going to be 2 multiplied by 0 for that other case, which is 1 is 0. So it's going to be 8 into 1 squared, just like that. And then we get 1 over 9 as our answer. So that's it for that one. Let's see the last question. I'm also happy that this video is almost done. Yeah, I've been solving for quite some time now. Okay, so this is going to be what? This is going to be, so we ask ourselves, can we integrate, can we simplify this? No. Do we have a function and it's integral? Then yeah, no, we don't. So what are we supposed to do? So since we don't have the function and its derivative, we need to let something to be equals to u. So for this case, we're going to say our u is going to be equals to x plus 1. With derivative with respect to x, we're going to get that the u is equivalent to the x. We make x the subject of the formula, so x is equivalent to u minus 1, just like that. And then from here, we are going to rewrite everything with respect to u. So again, we can also do our limits. So our limits with respect to u, so u is going to be what? Our upper limit will be 8 plus 1. Our lower limit will be 0 plus 1. This is 9. This is 1. So we rewrite everything now with respect to u. So this is going to be 9, 1. And then our x is equivalent to what? X is equals to u minus 1. So now I'm rewriting everything with respect to u. So, and then our x plus 1 is equals to u. Then this u will be to the power 3. This will be u to the power 3 over 2. And then dx is equals to du. Then from here, I'm going to make each numerator term to have its own denominator. At the end of the day, I will have u 1 minus 3 over 2. So 1 minus 3 over 2, 1 minus 3 over 2 on your calculator. There, when you press, you'll get this is equivalent to minus half, because of it will be u divided by u to the power 3 over 2. So it will be 1 minus 3 over 2 at the end of the day, and then you'll get this. And then minus u to the power minus 3 over 2. Then du. Then from here, you can see it will be, you can also see that it's easy to integrate now. So let's integrate. So when we integrate this is going to be u to the power negative half plus 1 is going to be give us positive half divided by positive half minus, and then u minus 3 over 2 minus 3 over 2 plus 1, it gives us negative half. Negative half divided by negative half. We put our limits, 9 is to 1. Then from here, we substitute our limits into there. Then this is going to be 9 to the power of half divided by half minus, okay, we can say plus, and then we put 9 again to the power negative half divided by half minus what? We do the same thing, but we substitute the lower limit now. This is going to be half divided by half minus u, which is 1 to the power negative half all over, okay, I can say plus here so that I can write the positive 1 here. And then you punch everything on your calculator here. You'll get 2, 9 to the power of 1 over 2 plus 2 multiplied by 9 to the power of negative to the power of negative half, and then minus into 2 plus plus 2 multiplied by 2 plus 2, because that will be okay. That's 2 plus 2. We should be able to get our 8 over 3, and then that's it for this question. I hope you got it. You can also go about substituting x plus 1 back into here, so that you can have, so if it's x plus 1 as our u, therefore our or here you can say x plus 1 to the power of half divided by half minus what? X plus 1 to the power negative half divided by negative half. You put your limits there. Your limits are going to be the one for x, so 8 and 0. Then you will also get the same answer. So yeah, that was it for this lesson. I'll catch you on the next lesson. Take care.